All right, so we're going to work through the one example that we skipped using the graphing utility and then the last one that we didn't get to. The one that we skipped was this one. It said use a graphing utility just to graph this. So I'll show you how to use the TI. I have like the TI 84 Plus, but I'll also show you how to use the app if you don't have it. You guys will need it for your chapter 1 test, which is like not next week, but the week after. So you do need access to one. You just don't need it for tomorrow's quiz. Okay, so this is the other example that we left off with yesterday. It said graph the following equation using intercept, symmetry, and additional point. So we're going to start without the calculator, and then we're going to use the calculator to confirm it. So if I want to find the x-intercept, then the y-intercept, then I'm going to do the symmetry. X-axis, just like we did yesterday. Y-axis. Origin, and then at the end we're going to put it all together to graph it. What do I do to find the x-axis? The x-intercept. Good, so I get 0 equals the square root of x plus 2. How do I get rid of a square root? Good. Square both sides of your equation. And 0 squared is still going to stay 0. X plus 2 is what's left on the right because the square root and the square are going to cancel out. And then I would subtract the 2, and I get x equals -2. So -2, is my x-intercept. What do I do to get the y-intercept? Good. So I get y equals the square root of 0 plus 2, and y is the square root of 2. So 0 square root 2 is my y-intercept. Now, if I'm giving that as an answer, which you'll need to do an x-intercept, y-intercept as an answer, you will leave it as square root 2. You'll keep it exact. But when I go to graph that, I have to approximate it. So what's square root 2 approximately? Like a 1.4. How do you know that? You put it in your calculator. What if you didn't have your calculator? How do you approximate a square root if you don't have a calculator? What two perfect squares is it in between? 1 and 4. So I know it falls between the square root of 1, which is 1, and the square root of 4, which is 2, right? And then we totally approximate it. Like if it's 1.4, 1.3, 1.5, I'm not going to notice a difference on your graph, okay? It is an approximation. When you give the answer, you keep it exact. When you graph it, you're going to approximate. All right, how do I test for symmetry for the x-axis? Change the y to -y. There's nothing to simplify here. Does this match the original? No. Are every term the opposite? No. For y-axis, I change the x. Still nothing to simplify. Doesn't match. And not all are the opposite. So this is also a no. And the origin, change the y and the x. Doesn't match. 2 of the 3 have now been the opposite, but still not all of them. So it's still a no. Now I'm going to pull in a graph. We're going to plot the information we've got. Yep.
So for the origin to be yes, the 2 after -2?
Yep. Or it would have to go back to the original, but yes, one of those. All right, so I'm going to plot -2, 0, and then 0 and 1.4. Do you remember what a square root graph looks like? It's that like a half a parabola turned on its side, right? A little arc that's pointing to the right. Let's pretend we don't know that. And this is 2 points is not enough information to graph it. I can choose to plug in some additional points or use my symmetry. The fact that there's none, so if there was y-axis symmetry, then whatever's happening on the left would also happen on the right, and it would be something like this, and it would produce almost a parabola. Sorry, it would be like this, okay, which obviously does not match. If it has x-axis symmetry, then whatever's happening above is going to happen below, and it would produce almost a parabola turning on the right, which obviously still does not match. Neither of those exist, which is consistent with my arc to the right. If I plug in a point from behind the -2, so let's say I plug in -4 just to plot a point, I would get y equals the square root of -4 plus 2, y equals the square root of -2. What's the square root of -2? It's an imaginary number. Can you graph an imaginary number on a rectangular coordinate grid? No. So that tells me there are no points over here, which again is consistent with my arc pointing towards the right. So just to confirm, I'm going to plot one more point. I'm going to plot 2. And I get y equals the square root of 2 plus 2. Or square root 4, which is 2. And now I'm confirmed that my arc is pointing toward the right.
On that one, once you do the square root, is it plus or minus 2?
Only if if you're bringing in a square root, is it plus or minus? If the square root's already there, it is the natural square root.
Okay.
So if it said x squared equals 4, and I go to bring in the square root, so I square root both sides, that's when it's plus or minus. When the square root already exists, it's just the positive square root. Questions? All right, let's graph this. So I'm going to go back to the graphing utility. I'm going to go to my y equals. I'm going to clear out what's there. And I have to do the square root of x plus 2. So square root is above the x squared. Square root x is the xt theta n button plus 2. Hit enter. Hit graph. And there it matches what we just found. On the app, all right, I'm just going to go through this real fast. Overall, you guys did really good on the class kick, which is great. Yes, I did. Otherwise, it wasn't factorable. All right, so this was, if I found a mistake, I try to correct it on your class kick. But the first one, for x-intercept, you plug in 0. You could either factor that or use your even root, but you should get plus and minus 3, so be careful there. Some of you just square rooted and kept the plus. The y-intercept, you plug 0 in for x, and you get 0, -9. The second one, if I plug in a negative y, only the y changed, so it failed the x-axis. I plug in a negative x, the values that had x's changed, but not the y, so it failed the y-axis. But when you plug in both this time, every single sign is the opposite that it began with, and so it is symmetric to the origin. And then this was the last one, so I did change that to 5 to a -5 because otherwise it wasn't factorable, and we're not doing quadratic quite yet. So the x-intercepts, you had to factor that, x minus 5 and x plus 1. And then you got an x at 5 and -1. The y-intercept was 0, -5. Then I found symmetry, none, which means it's not symmetric to the y-axis, it's not symmetric to the x-axis, and it's not symmetric to the origin, which confirmed my graph. When I plotted those 3 points, I knew it was a parabola, so I just connected them. If you needed more points, this actually dips really low down under your graph. That's totally fine. When I'm grading this question, I'm looking to see are your intercepts marked and is the overall shape correct, okay? You don't need to draw a bunch of points in there unless you're unsure. And I would say that's the thing I would say for the very end of your quiz. I would work all the way through, make sure you have time to complete it, and then go back to something like that. The quiz review is on Canvas. It goes through the beginning. Obviously, the top one is your classifying your triangle, if it's equilateral, isosceles, and or right, or it could be none of those, okay? So for these, you need the distance formula. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. The solutions to this will be posted later today, but it is there. And I don't collect the quiz review. I figure if you want a good grade on the quiz, you're going to do it. and I want to make sure you have the solution so you're checking as you go. Should you choose not to do this quiz review, then you can suffer the consequences all on your own tomorrow when you go take your quiz and you don't feel prepared, okay? All right, so those 2 questions are classifying. Then comes the graphs. There are a bunch of different kinds of graphs on here for a reason. I want you to do them all. Some are parabolas. Some are parabolas turned on their sides. Some are absolute value. You could get any of these things, so you want to make sure you're prepared for any of them, okay? The next slide has your circle. You're going to graph and sketch that. Actually, I needed to change this. Let's make this a 14 because it's not a perfect number on your quiz, so don't get used to it. So change 7 so that it equals the number 14. So my radius there is going to be the square root of 14, then you're going to have to approximate it. That's the reason for that, okay? It's going to happen on your quiz. You might as well try it out. I'll change it, but if you already opened the quiz review, change number 7 to 14. Then comes the equation of the circle, 1 where you're given the center and the point. So this is your HK, this is your XY. And then 1 where you're given the endpoints of the diameter, which was like the one we did on the warm-up yesterday. For these, you need your x minus h squared plus y minus k squared equals r squared. And for the second one, you need your midpoint. So this is the circle, this is the midpoint. x1 plus x2 over 2, y1 plus y2 over 2. And then there's a graph of the scatter plot just for you to practice that. Okay, you're going to draw a scatter plot based on that, and you're going to make an inference. Remember, you want things like as this one increases, or as this one increases, this one decreases, or something like that, specific to the data. So you can't just say it increases. You need to make a comparison with the actual specific terms on that chart. Questions for me as far as quiz goes?
We don't get these formulas, right?
No, you'll get no formulas on this. Yeah. And no calculator for you guys.